So with navigation applications, you're needing to know where exactly to go in reference to a compass. So if you've never seen a compass before, we're going to talk about it. So the first part says the course of an object, it's usually a plane or ship or some other type of object, is the angle that's measured clockwise from the north direction to the direction of your object, and the course is called a bearing. And that's usually denoted using 3 digits, usually. So for questions like this, we're actually going to define what a bearing is so you kind of know what it means. A bearing is a measure of an acute angle measures, I'm going to put the acute angle, a path or line of sight makes with a fixed, bless you, north and south line. A bearing measures the acute angle a path or line of sight makes with a fixed north and south line. So for these examples down here, for example 1, all 4 of these we're actually going to draw. When it says your north and south line on a compass, north is on top, south is on the bottom. So if you don't know the direction of a compass, I usually remember it by never eat shredded wheat. Some people say never eat sour watermelons. There's plenty of other ways you can remember it. But I just need you to memorize that north, east, south, and west is going in this direction clockwise. So I'm going to do that for all of my compasses that I have. So what we're going to do now is we're going to actually identify where is the bearing of 100 degrees. So having a bearing of 100 degrees means you're going to start with your north line and you're going to go around to where you're going to get to 100 degrees. Keep in mind, this is not the same as the unit circle. It's a compass. So every time you have intersections of your compass, it's going to intersect at a 90-degree angle every single time. All of these intersections are 90 degrees. So keeping that in mind, if I was looking for 100 degrees, you're going to start with your north line, because that's what it said here. Start with your north direction clockwise. So I'm going to go down. This is 90 degrees. 100 would be probably somewhere in here. This whole angle would be 100 degrees. We're going to do the same thing for 65 degrees. Even though the 0 is there, it's still 65 degrees. So again, we're going to start with our north line, and we're going to go around clockwise to 65. Well, 65 is going to be less than 90, so I'm just going to put 65 degrees right here. And of course, I don't have a protractor to actually measure it, but it'll be close. Go ahead and do the same thing for 210 and 320. See, based on what we've talked about, start with your north line, the north direction, and go clockwise around to figure out where your angle will be. So keeping in mind that each of these little intersections are 90 degrees. 210, this is like 1, 2, 3, 4, the quadrants. This is going to be in quadrant 3. For 210 degrees, it's going to be somewhere around here. So all of this going around is 210 degrees. 320, is it going to be in the first, second, third, or fourth quadrant? Fourth. It's going to be somewhere up here, probably close to that north line. So this will be all the way around. This will go 320 degrees. All right, perfect. So for the bottom portion, for this top part right here, this is just bearing. So it's telling you if you're starting from a north direction, where you would go around your little compass. The next part is a little different. So it says sometimes the bearing is used to describe north, south, east, and west. Instead of just saying bearing, you would actually say north, south, east, and west. You'd tell exactly where that direction is based on your compass. So here's how you're going to label it, and here's how you're going to graph it below. So the first letter is the direction in which you start. So the first letter is the direction you start, while the second letter is the direction you're going to go. You're typically going to start with a north or south direction, and then you're going to move east and west. East or west, I'll say. East or west. You're not going to move both ways. So let's go ahead and look at our graphs below, or not our graphs, our compasses. So for each of them, I'm going to label never eat shredded wheat for each of them. Remember, just like with the ones on top, for your little compass, each of these between north and east, east and south, these are all 90 degrees, so keep that in mind. So for this first question, it says N 15 degrees E. What this means, and the way you would read it out, is north 15 degrees to the east. That's what that literally means. North 15 degrees to the east. So what it's telling you to do is start in the north direction, and you're going to go towards the east. Is the east to the left or to the right? To the right. So you're just going to go to the right about 15 degrees, very small, and this would be how far you go. North, 15 degrees, east. That's all you would do. So for the next one, same thing. This is S105W. Okay, well, S represents south, 105 degrees to the west. So you're going to go south 105 degrees to the west. So I literally want you to start down here, south, and you're going to go to the left towards the west. The issue is, remember how I said each of these are 90 degrees? It's not going to stop right here. Where's 105 going to be? First, second, third, or fourth? Say it again. Fourth. It's going to be in that fourth quadrant, so right over here. It's going to be a little bit bigger than 90. So it's okay. You're starting south, and you're going all the way over to 105 degrees. Do the same thing for the next two. First, write out what does it mean, S 280 degrees east, and so on, and then actually graph it out. Where is it going to show up on your little compass? All right, so let's graph this out. South 280 degrees to the east. We're going to start here. We're going to go towards the east, but we're going to go 280 degrees. Is that going to be in the first, second, third, or fourth quadrant? First, second, third, or fourth? Which one? Third. It's going to be in the third one. So it's going to have to go all the way around, but it's going to go starting from the south towards the east, and it's going to go all the way around to here. And it's okay if it ends up in a different quadrant. It is perfectly fine. For the last one, it's not as ugly. North 75 degrees to the west. This one is right before that 90. So that would be where you're going. Give me a nod or shake. Is this okay? All right, perfect. Let's look at the top of the next page when you have it. If you have a question, now's the time to ask. All right. On this top portion, it says sometimes a degree is not given and the direction is implied. So with this part, it says given your north and south lines, draw the following bearings. So we're just going to make a very simple bearing for each of them. So northeast, first, let me actually write out all of my sides. This is north, east, south, and west. I'm going to go ahead and go around each of these, and I'm going to label where northeast is. Okay, well, northeast is here. Southwest is down here. Where's south? If you're proceeding south, where would that be? It's pretty much straight down. Literally straight down this compass, right down here. Straight down. Which means proceeding west would be to the left or to the right? To the left. So it says at the bottom, what is the bearing for each of the above courses? So it's not asking for anything specific. It just wants you to estimate. So for this one here, northeast, this looks about maybe 45 degrees. So from here to here, I would say that it's about 0.45 degrees. I'm going to be 100% honest. Sometimes I forget to put that 0 and I just put 45 degrees. It's fine. For the next one, again, whenever you're doing the bearing, and I'm going to write this out, you want to start with, if I could spell with correctly, the north direction. And that was literally just from the first page. You're going to start with that north direction. So if you start with the north and you go around to where your angle is, your bearing would be a little more than 180. So I'm going to say this is about 45 degrees from here. So I'll add that to make it about 225. If you're proceeding south, how far is that in degrees? If you're going from north to south, 180. What about from north to west? 270. Perfect. So with all of this stuff done, now we can actually do the questions below. I'm not going to do every single question, but I'll do a few. So for the first question, right below it, we're going to graph this out. Now, every time I say graph, I mean we're going to draw the picture, but I'm just so used to saying graphs. So what we're going to do is we're going to draw out your image for this, and then we're going to actually solve to figure out what the question's asking. So this says a ship sails 12 kilometers south, followed by 10 kilometers along a bearing of 290 degrees. How far is the ship from its starting point? And what is the bearing of the ship from its starting point? Okay, so there's a lot of things that you have, so I'm going to do it one thing at a time, so do this with me. It says a ship sails 12 kilometers south. So let me draw out my compass. It's just a very small compass. South means you're going straight down. It says followed by 10 kilometers along a bearing of 290 degrees. Okay, let me draw out my bearing. Bearings start where? North, and it's going to go all the way around to 290. Okay, so this is 90, 180, 270. 290 will be somewhere in this fourth quadrant up here. The reason why I have you guys draw this out is so you have an idea of what your picture will look like. And then it's asking just the questions. Okay, let's start by graphing this out. So put your pencil down just temporarily. I'll have you pick it up in just a second, but I want to show you how I go about graphing this. If you look at where this graph is going, it's going to start by going down, and then it's going to shoot out to the left-hand side over here because of this 290 degrees. So what I tell my students to do first, don't draw anything yet. I'll do it with you in a second. We're going to draw our compass first. Don't draw anything. And from here, we're going to go south 12 kilometers. Give me a nod or shake. Are you okay with what I just did? South 12 kilometers. The next part said followed by. So followed by means you're going to change direction. So I'm going to draw another compass. And this one's now going to go along a bearing, 10 kilometers, along a bearing of 290 degrees. So from here, I'm going to go out to the left like I have. So I'm just going to shoot this out about 10 kilometers. Go ahead and draw this out. You're starting with that south direction, going down 12 kilometers. Draw down a decent amount, 12 kilometers. Stop. Draw a new compass, and then shoot it out to the left, up to that 290 degrees, and label that 10 kilometers. That's it. That's all you're doing. So now it's asking two problems. Before I finish this, have I lost anybody with what I just did? All right, let's go ahead and finish this up. It says, how far is the ship from its starting point? Well, it started right here. So what we're trying to find, and I just dashed it just to show you what we're looking for, we're trying to find this X. That's what I need to find. This is currently where my ship is. I'm going to label this as A, because that's where we're starting, and then this guy here is going to be B. That's where it is after. I'm just giving it some variables. So we need to find X. Okay, well, before we do anything else, is there any information that I don't currently see here that I could put on my triangle? Because technically this little item here is my triangle. I only have two sides. I need to have something else. Okay, we need an angle. We need a degree. The only degree I have is 290 degrees. I can't put 290 in here. That's too small. This 290 degrees was the angle going around from your north direction. So all of this going around is 290 degrees. What does that probably mean that this is? Not 20. How'd you get 70? It's pretty much just subtracting. You're taking 360 and subtracting it from 290. Yeah, it's going to be 70 degrees. So let's go ahead and solve for X. So before I move on, have I lost anybody with how I just found 70? It's literally just on that compass. You know it goes all the way around is 360. just subtract it. Find out what that little angle is. Bless you. If I wanted to find x, Fatima, what would I have to do to find x? Look at what you have. Okay, and that angle's included. So what could I use? Oh, wow, your voice has traveled. Yes, Fatima, you're going to use law of cosines. So for this, to find x, I'm going to write this out. To find x, we're going to use law of cosines. So we'll have x squared is going to equal, okay, I'm going to add my two sides. So I'll do 10 squared plus 12 squared minus 2 times 10 times 12, cosine of the angle that we just had, which is 70 degrees. Quick question. Can I just plug all of this into my calculator? Yes or no? Yes, it should be a 12. Thank you. Let's try that again. Can I plug in all of this in my calculator? Yes or no? Yeah. Yes. Edgar's nodding his head. Yes, we can do that. So in new document, I'm going to add my calculator, change this into degree mode. We have 70 degrees, so change it into degree. I'm going to go down to settings and status, document settings, and change this into degree. All right, so let me plug all of this in. I got 161.9. Am I done? What do I still have to do? I have to square root it. Okay, so let me write that out. I have x squared is going to equal, and then I'll square root both sides. So I'm going to square root that last answer, and I'll get 12.7246. For this page, I'm just going to round all of the answers to one decimal place, so the nearest 10th spot, and so that way we won't have to worry too much about it. So 12.7, and this is in kilometers. So that's that distance. All right, so that's one part of my answer. The second part says, what is the bearing of the ship from its starting point? Okay, so let's look back at the image that we have. If we're looking at the bearing of the ship from its starting point, the ship is pretty much starting from A. I want to find out what is this angle going to be. So I want to find out what theta is. That's the bearing where that ship is going. So the ship is coming back home. It's going to find out this bearing for all of this space. How could I find it though? What could I do? We could use law of sines. And what are we going to find with that? Are we going to find theta? Yeah. Not quite. Theta includes pieces that are outside of your outside of that triangle as well. We're going to have to find this angle inside first and then add it to whatever's outside. So let's go ahead and label. I'm going to label this as angle A inside. So this little guy here. Let's go ahead and find that angle A. So I'm going to put find angle A, and I'm going to put, to find that, we're going to use law of sines. So you're going to have sine of the angle that we're given, which is 70 degrees, over x, which is 12.7246, and then sine of angle A over 10 kilometers, because that's directly across from it. Go ahead and solve for A. We got 47.6026. Is that my theta that I was looking for? Yes or no? No, it wasn't the angle that I was looking for. Instead, this is just the angle that we have right in here. How am I going to find this theta though? Say it one more time. Adding 180 to it. Take 180, because we already know that it's true to say that this is 90 degrees and so is this. We're going to add that 180 to this little angle here. So add 180 to angle A, which is what we just solved for. And then once we have that, we'll have our final answer. So I'm going to take that number and add it to 180. So theta, which is the bearing that we're looking for, is 227.6 degrees. So theta is 227.6 degrees. That's that bearing. On a different question, some students ask me, well, can we write it with north, south, east, and west? Whenever I ask for a bearing, guys, I just want you to look at your north direction and then write out where it's going around to that given, or to the angle you're trying to find. For the north, south, east, and west, I'll show you in a later question how I'd want you to write that. So right now, I want you guys to try to draw. I'm not going to do the whole question with you, but I want you to draw what this image will look like. It says a ship sails 125 kilometers west, followed by 100 kilometers along a bearing of 320 degrees. And it asks you how far is the ship from its starting point and what is the bearing of the ship from its starting point. So it's the same question, but just written a little differently. Try to show what that image, that picture, will look like for this question. First thing I would suggest doing is when it says a ship sails 125 kilometers west, draw where west is, because by starting out to showing where your ship will go, it will help you with actually showing the picture. So if it's going to the west, it's going in this direction. So that's going to the west. Followed by 100 kilometers along a bearing of 320 degrees. So here's my compass. It's going to go around 320 degrees to land right here. So it's going around this direction to create that bearing. Okay, so let's see what we have. I know for sure it's going to go to the left, and it's going to go to the top left area. So when I graph this out, or when I draw this out, I'm going to probably start down here. Main reason why I'm starting down here is because I know it's going to need to go to the left, and then it's going to need to shoot up in that left direction. So I'm going to start this out here. The ship is going to start going 125 kilometers to the left. So this is 125 kilometers. And then after that, it's going to be followed by, let me draw my compass again, 100 kilometers along a bearing of 320. Well, if I go all the way around, 320 degrees is somewhere up here. And they're going 100 kilometers for that. The question's asking you to find what is how far is the ship from its starting point? Started down here. That would be what you're solving for. So, like I said, I'm not going to solve this whole question with you. I just wanted to give you an idea of what it's supposed to look like, so that way you have an idea later on when you're doing this on your own. All right, after you have that graph, are there any questions, or that picture for question 2? Are there any questions before we move on? All right, when you're good, let's flip it over to the next page. I'm going to do 2 questions, and then we'll move on to the last page, the last couple pages. All right, I'm going to do questions 4 and 5 with you guys. So for question 4, this one is talking about the 2 towers. Using what you just saw on the other page as far as drawing your picture is concerned, try to draw this one before I do. I'll give you about a minute head start. Question 4, read the question, guys. It says 2 towers are 20 miles apart. This is the question I'm doing, not 3 above, because some of y'all can't count. Okay, so for question 4, first part it says that you have 2 towers that are 20 miles apart. Tower A is due north of Tower B. Okay, so due north, that direction is straight up. It's literally going vertically, straight up. A fire is spotted from the towers, and it's at a bearing from Tower A and Tower B, and that is south 56 degrees to the east. So southeast is here, so south 56 degrees to the east is here. And remember, it's going here to here. I'm purposely drawing that little arrow going from south to east for a reason. And then from north to east, that would be here, 34 degrees, here to here. And it's asking how far is the fire from Tower B? It might have helped to say that Tower A and Tower B is south 56 degrees east and north 34 degrees east, respectively. So Tower A, this is the direction. Tower B, this is the direction. So hopefully that makes sense. Okay, so first thing that I noticed is it said that Tower A and B, or Tower A, is due north of Tower B. Does that mean that A is on top or B is on top? A. Okay, so up here at the top, I'm gonna draw my little compass here, draw my little compass here. Tower A is due north. That means that A is right above. And that distance between them is 20 miles. A fire is spotted from the towers, and it's at a bearing where Tower A is south 56 degrees east. Well, we talked about it here. So that's going to be going in this direction, southeast. And Tower B is north 34 degrees east. It's going up. So it's going to be about here. This is your fire. I'm not given anything else. What could I label hopefully, is there any other sides or angles that I can plug in? When it said that tower A is south 56 degrees east, remember how I drew this little measurement here to show that it's going from here to here? Is that the same as the interior angle here? Yeah, it is, because it's going from the south to the east. Yes, that will work. So this angle here is 56 degrees. And then the angle down here, I just want to double check. This angle for B is going from north to east, right? All right, so this angle here is going to be 34 degrees. Once you have that, how could I solve this, Odalis? What can I do? Yes, you're the first one today. You get that absolutely right. Yes, you're going to use a triangle sum theorem. What are you trying to find with that?
The angle for the fire.
Angle for the fire. So we're going to add angle A plus angle B plus angle F for the fire and set that equal to 180. Y'all solve it. What's angle F? 90 degrees. What does that mean? It's a right triangle. And I know you're looking at me like, Ms. Tapia, that is not a right triangle. I know. Let me redraw it. I was a little obnoxious with that far side, but this is 90 degrees. This is the fire. This is A. This is B, which means that 20 is what? On this right triangle, what is that? Your hypotenuse. Which means that this down here, angle B, is 34 degrees, and this guy here is 56 degrees. I have a lot of students asking me in the middle of their test for some reason if they can use law of sines and cosines for this problem here. Whenever you have a 90-degree angle, you don't need to use law of sines. Law of sines would be a good option, but you don't need to use it. The reason why is because when you were back in geometry, you learned how to deal with 90-degree angles. When you had a right triangle, what did you use? Not just Pythagorean theorem. SOHCAHTOA. You're just going to use SOHCAHTOA. You're going to use SOHCAHTOA. So in this triangle, I first need to figure out what the question is asking, because I haven't read that yet. It says, how far is the fire from tower B? Is that distance going to be AF or BF? BF. So you're trying to find that X down there. Okay, well, I could use either angle, either 34 or 56. I'm going to be a little lazy and use angle B, which is 34 degrees. And I'm going to use the trig function for the adjacent and the hypotenuse, which is going to be cosine. If you're like, Ms. Tapia, I really want to use sine and I want to use 56. I don't care. Do it. You should get the exact same answer. So cosine of 34 degrees is going to equal the adjacent over the hypotenuse. And then you're just going to solve. Double check. Make sure your calculator is in degree mode. And then we're going to plug this in. 20 times cosine of 34. And if you use sine of 56, it's completely fine. So X should equal 16.5808, which means that's approximately 16.6. This is in miles, so miles. That would be your answer. All right, let's go ahead and look at question number 5. So for question 5, it says 2 lookout towers are 50 kilometers apart. Tower A is due west of Tower B, and a roadway connects the 2 towers. A dinosaur, wow, okay. A dinosaur is spotted from each of the towers. The bearing of the dinosaur from Tower A is north 43 degrees east. A bearing of the dinosaur from Tower B is north 58 degrees west. You need to find the distance of the dinosaur to the road that connects the 2 towers. Using the information we've been doing so far, draw out where your bearings are. What does it mean for north 58 degrees west? All of that. And then try to see if you can sketch out a little picture for this. See what you can do. I'll give you about a minute. All right, so I have my directions labeled. We have west, which is going to go straight to the left. We have north 43 degrees east, which is in this direction. And then we also have north 58 degrees west, which is this direction. Okay, so just by looking at the directions that I have listed, it looks like it's going to be left. It looks like it's going to go up to the left, or excuse me, up to the right, and then again up to the left. Okay, so I'm probably going to need to start my graph or my picture down here towards the bottom, just so that way I can actually go west, and then I can go up into the right and then up and to the left. So that's why I always have you guys draw it where the graph is going or where the picture is going. So it says two lookout towers are 50 kilometers apart. Tower A is due west of Tower B. This is Tower B. This is Tower A. Since it's due west, it's literally west of it. That distance is 50 kilometers. Next, it says that the dino is spotted from each of the towers. The bearing of the dinosaur from Tower A, okay, looking at Tower A, is north 43 degrees east. We're going to go in this direction. So I'm just going to have this go up, north 43 degrees east. And then the other part for Tower B is going to go for the bearing of the dinosaur from Tower B is north 58 degrees west. It's going to be something like this. This point is your dinosaur. Okay, so let's check something really quick. On the last question, you guys told me that the inside angles were just going to be the angles that we had here. Is that going to be true for this question? Okay, not just because I asked, but yes, it's not going to be true for this one. Since north 43 degrees east is going from the north to the east, this angle outside is 43 degrees. What does it mean that this angle in here is going to be?
90 minus 43.
Okay, what's 90 minus 43?
47.
47, yes. Same thing for this one as well. That's why I kept drawing, this is where you're going, and even over here, this is where you're going. So that way you knew that this is not going to be an interior angle. So for B, it's going to go north 58 degrees west. North to west is 58 degrees, which means that this angle is going to be, correct me if I'm wrong, 32? Okay, good. All right, cool. I need to figure out, and it specifically says find the distance the dinosaur is from the roadway. This is going to require you to take a quick trip to geometry and think about what this definition means, because what this dashed line is what you're finding. This is what's called an altitude. Altitudes go from a vertice to one of the sides in your triangle, and when it does, it creates a 90-degree angle. So this is technically, I'm going to draw this out. This is one right triangle, and here is your other right triangle. You're trying to find that vertical line that we just drew, which is your height. That's what you're trying to find. All right, so first step for this. Just us talking about what we just looked at with the green and orange highlighting. Which side do they both share? No. What side? H, this vertical one here. Both of the green and the orange triangle share this height. Okay, so we need to think. If I know that this is 90 degrees, this is one right triangle, this is the other right triangle, we can use SOHCAHTOA. The issue is I need to figure out how to actually make my ratio for this. Before we do, I want to add one more thing to this. With the definition of an altitude, it does not automatically make the base side length down here. It doesn't make it a bisector, which means that both sides are equal. So don't assume that this is 25 kilometers and don't assume that this is 25. What I'm going to do is I'm going to label this as side X, which would mean this side would be what? 50 minus X. Thank you, Heidi. You're going to take whatever that X is and pretty much just subtract it from that 50. Yeah, you could write it the other way. It's still going to give you the same answer. If you put 50 minus X and then X over here, it'll give you the same answer. Okay, so let's go ahead and solve. So for this question, the first thing I'm going to do, I'm going to start with the green triangle, and I'm going to use SOHCAHTOA. Remember how that you guys just told me that these two triangles share side H? I want to get H to be by itself in both of my trig ratios that I'm about to use. So in this green triangle, don't worry about finding this upper angle up here. There's no point. So let's just use 47 degrees. This is opposite. This is adjacent. So we're going to use tangent of 47 degrees is going to equal the opposite over the adjacent, which is just X. Remember how we said H is the shared side? How could I get H alone in this equation? What would I need to do to the X? Multiply it by X. So X tangent of 47 degrees is going to equal H. That's part one. Second part, we're going to do the same thing, but in the orange triangle. In that orange triangle, even though I didn't put it, this is also a 90-degree angle. It's a right triangle. So I can use SOHCAHTOA again to find my H side. Okay, we'll just use the 32 degrees. This is another tangent of 32 degrees is going to equal the height, over, in this case, the adjacent side is 50 minus x, and that's okay. If I wanted to get h completely alone, you could multiply both sides by this 50 minus x. It's not going to change anything. Or you could cross multiply. So I'm going to write this as h equals 50 minus x tangent of 32. Because look up for a second, guys. This 50 minus x needs to be multiplied by that tangent. What can I do now? Set h equal to h. Both of those equations, set them equal. Good job. So this first h over here to the left, I'm going to make x tangent of 47. And remember, that x is being multiplied, is equal to the other h, which is 50 minus x tangent of 32. You've solved similar questions like this when you were back in Algebra 2. So for this question, let's just talk about it. I need to solve for both of these x's because that's the only thing I can solve for. How would I solve for it? What do I need to do with that tangent of 32? I can't divide it yet. I need to get both of the x's by itself. What do those parentheses mean? You're going to distribute. You're going to multiply. So we're going to distribute it to both of these. You can do that. X times tangent of 47 degrees equals 50 tangent of 32 degrees minus x tangent of 32 degrees. Made it fit. And then from here, this is an ugly version of this problem, and it's a little more fun than that problem that I'm about to write. 5 minus 2x, we'll write it like that. Ignore this part at the top. How would I solve this? Move the x's. This will give me 6x equals 5. Then what? Divide. You're going to do the same thing here, but you want to make sure that you keep track of tangent of 47 degrees, bless you, and tangent of 32 degrees. Those are actual numbers. So unlike the 2 and 4 that I just did in this little example that I erased, you can't just add both of these numbers. So I want you to go ahead and move the x for the right-hand side, move it over, and try to see if you could isolate x completely. So move that x tangent 32 degrees, move it to the other side, and try to see if you could simplify it from there. This is just basic Algebra 1. So we're going to add that x tangent of 32 degrees, add x tangent of 32 degrees. I just said this. You cannot subtract or add both of these tangents. This will be x tangent of 47 degrees plus x tangent of 32 degrees equals 50 tangent 32 degrees. I have two x's. How do I make them one? Factor it out. How do I get rid of all the stuff in the parentheses? Can't add them up yet. I mean, I could. It would just be a little bit of a waste. Say it again. Divide. We can divide both sides. You can add both of those numbers, so I don't want to get it wrong. You can't add them, but it's not really going to help us with isolating x. At least not yet. So tangent of 47 degrees plus tangent of 32 degrees. And I'm going to do that over here too. I don't know if I can make this fit. Tangent of 47 plus tangent of 32. Barely made it fit. These are going to cancel. X, not t, x is going to equal all of this plugged into your calculator. So we're going to have, not 40, 50 tangent of 32 degrees over tangent 47 plus tangent 32. Be careful before you hit enter. Make sure it looks just like it should have on the paper. 50 tangent 32, tan 47 plus tan 32. All right, perfect. It's still in degree mode, which is important. So we're going to have 18.4084. Double check. What was I solving for originally? Was I solving for x or h? What was I trying to find the answer to? H. Okay, well, I found x. Okay, don't panic and be like, oh my gosh, Ms. Tapia, we were doing that for nothing. No, we were doing it for something. What do you think I'm going to do to find this height? Plug the x back in. Take this x that we just solved for, take this x that we just solved for, and plug it into either one of these equations. Which one am I probably going to use? First or second? I'm lazy. I'm going to use the first. So I'm going to take that x, substitute it in, and multiply it by tangent of 47. If you really want to do the second one, you can do it. You're just going to have to subtract, which I think is too much work. So for step 4, which is your last step, we're going to take x tangent of 47 degrees, and we're going to make that equal to h. We need to plug in that 18.4084. Give me the whole decimal. What's the height? 19 point what? Perfect. And if you round that to the 10th spot, what is that? 19.7 what? What's the unit? Kilometers. So km. That should be your answer. So, a little bit intense, but let's go ahead and look at the last couple pages. I'm going to talk about example 4, which is nautical miles, and then after that, we're going to do 2 very quick questions. So for example 4, a nautical mile. So a nautical mile is pretty much a distance at sea. So I'm going to write this out. This is a distance at sea or in the air. So at sea or in the air. That's usually what a nautical mile is. If you want to calculate a nautical mile, it's measured in knots, K-N-O-T-S, times time. That's going to equal a nautical mile, which I'm going to abbreviate as NM. Keep in mind, guys, that knots times time, this is just a distance formula. Knots is a rate, so it's a speed. And then time, of course, is just time. So we're still using formulas that you've seen back in Algebra 1. The only difference is we now just have knots and time. That's all for nautical miles. So we're going to do 2 quick questions. I'm going to do question 1 and question 3 with you. So for question 1, this one says a ship leaves port at noon and has a bearing of south 29 degrees west. Let me draw that out. Southwest is in this little area. The ship sails 20 knots. How many nautical miles south and how many nautical miles west will the ship have traveled by 6 p.m.? Okay, so nautical miles south, so that means it's going straight down. How far straight down? And how far west, which is going to be to the left. Okay, so let's figure out what this is going to look like. First, we need to draw out what this is going to look like. It looks like it's going to go from its starting point to the left. It's going to go down, and then it looks like we're trying to find how far south and how far to the west this is going to go. This is how I would graph my problem out. All right, so I'm going to start with my bearing of 29 degrees southwest. So I'm going to go southwest 29 degrees. That's pretty much where the ship is. What I need to find out is how far south and how far west the ship actually went. That's all you're finding. So there's several things that I need to plug in or that I need to label. First things first, can I assume that this is a 90-degree angle? Where does south and west meet at? What type of angle? If it's south and west, what kind of angle do they meet at? It's just 90 degrees. It's just 90 degrees. We did that on the compasses before. So, especially for this part when it's saying 20 knots. What's the distance for 20 knots? Because this is a rate. I need to find the distance. If 20 knots is your rate, what's the time? How long did it take them to get that far where I just drew my little purple dot? 6 hours. How'd you get 6 hours? Noon is 12, and you're ending at 6. So that's 6 hours in between. That noon was extremely important. And then you're just going to multiply 120 nautical miles. So this distance along the part here, the hypotenuse really, is 120 nautical miles. So what you're trying to find is how far south, I'm going to label that with X, and how far west, I'm going to label that in Y, we went. There was one angle that I haven't dealt with yet, that 29 degrees. Okay, so double check. Is the 29 degrees going to be inside of your triangle or outside? Outside. So you're going from south to west. This is 29 degrees, and I forgot to put that here. South to west is 29 degrees. So what does that mean your angle is down here? 61 degrees. All right, you guys do it. It's a right triangle. You can use SOHCAHTOA. Plug it in. So I'm going to tell you first, find x. Second one, find y. Just use that 61, guys. Make your life easier. Don't worry about finding that missing angle. Find x, find y. All right, so these are the answers I got. So x, which is the direction south, this should be about 105.0 nautical miles. Yes, I've been rounding them to the tenths place, so yes, I want you to put that 0.0 to show that you rounded it to the tenths place. And then for y, which is the west direction, that's going to be about 80 or 58.2 nautical miles for that. So it doesn't matter if you use 61 degrees. I would suggest using it instead of finding the other, but it'll still get you the exact same answer. All right, let's go ahead and look at question number 3. Question 3 is the last one I'm going to do with you guys. All right, so for question 3, you should be able to do this without me, but I'm going to still do it with you. It says a ship is 45 miles east. Okay, let me draw east. East is this direction. And 30 miles south of your port. Hint, place your port at the origin. I don't know why there's another quote. The captain wants to sail directly to port. What is the bearing that he should take? Okay, so let's figure this out. It's going east and then south. Okay, so from the port, which I could label here as your port, you're literally going east 45 miles, and then you're going south 30 miles. The captain wants to sail directly to port, which is here. The question was saying, what is the bearing that he should take? Okay, so first things first. Since you have east meeting the south, you can make this a right angle. That can be done. But since I need to find out what the angle is, I need to figure out, not theta. I need to figure out, based on my little compass that I'm going to draw, what is the bearing? Because the bearing means you're going to start with your north line, and you're going to, or north direction, and you're going to go all the way around. You need to figure out what that is going to be. All right, so let's think about it. I know for sure that if I go all the way around, it should get me close to where my bearing is supposed to be. The issue is, how am I going to get it? So if I'm going up just to this side, what should I probably do? Something. What should I do? How am I going to find the bearing, which is pretty much this theta that's outside, this whole area that I have in this purplish color? How do I find that theta?
You find the theta inside.
Okay, I'm going to label the theta inside as a big A, so just some variable. Let's figure out what that angle is in here. Let's start there. So first step, we're going to find big A. Is that a tan trig function? Opposite and adjacent? Yeah, we could do that. All right, so let's use that first. Let's use SOHCAHTOA first. And we're going to do tangent of angle A is going to equal opposite. Be careful, guys. Opposite is 45 over the adjacent, which is 30. And then you were saying to use the inverse, right? Okay, good. We're going to use the inverse on each side. So tan inverse, and we're going to plug that in. Where's my calculator? So tan inverse of 45 over 30. Don't know why I put a decimal there. I don't know if that changes it. Nope, it doesn't. So A should equal 56.3099. Is that my answer? Okay, so let's think about it. Take a second and think, and then we'll talk. Since it's asking for bearing, it doesn't specify here, and I'm going to make this quick little note, which is what I talked about on the very beginning of this. Bearing means that you're starting from your north direction and you're going around to get this whole angle. If I just asked for you to write your bearing in reference of north, south, east, and west, you could just use this angle here. If you were to use this angle here, I would write it as 56.3 degrees. But what direction is it going in? North and west. So north, west. So if I asked for you to write the bearing in reference of north, south, east, and west, this would be a perfectly sufficient answer. But the question didn't specify that. It's asking for the bearing, so it wants this theta. How am I going to find this theta now? Subtract 360 from what? Say it again. The 56, what we just found. So step 2 is going to take 360 and subtract it from angle A, and that's going to give me my theta. So in your calculator, let's just take that 360, subtract it from the last answer, and we should get 303.69. So theta should equal 303.69, which is going to round up to about 7. So theta should equal 303.7 degrees. That should be your answer.